Hello everyone, my name is Putu Krsna and today we are going to discuss about friction forces and the experiment that we did. My student number is 240553125. I'm from Udayana University, and we're just going to jump right into it. The overview of this experiment. Now, this experiment was conducted to accomplish the objective of finding the static and sliding forces. The experiment was accomplished by measuring the static and sliding force of the wooden block using spring balance. Friction is a resisting force that acts along the tangent of the two surfaces. Now, this is going to be the equation that we're going to use in this experiment to find the force friction. Now, first is going to be static. F friction equals mu s times Fn. Mu s equals static force coefficient, while Fn is normal force in Newton. Now, the second one is how we find the F friction in kinetic. F friction equals mu k times Fn. Mu k is the kinetic force coefficient, while Fn is also the same. Normal force is Newton. Tools for the experiment. Now, what we need for this experiment to work is a wooden block, a rod, stopwatch, ruler, weights with variation of mass, table, small pulley, spring balance, and digital scale. This is going to be the procedure on how we are going to do the experiment. First, we scale the wooden block mass with the digital scale. Now, when we scale the wooden block mass with the digital scale, we're going to use three variations of masses with the block is going to be put by different variation of mass to make it heavier and to see what its effect is going to be. Then we're going to put the block on the table that has been prepared. Now, to measure friction, pull the block slowly with the spring balance till the block precisely moves. Then take note of the maximum pull force. Take the data and calculate the static coefficient with the equation that has been provided. Make a graph between the pull force and the force friction. Second experiment procedure, searching for a kinetic force coefficient. Now, this is going to be ultimately the same with the previous procedure, but the difference is going to be we are going to measure kinetic friction. First, we're going to scale the wooden block mass with the digital scale, and as previously said, we're going to add some masses on top of the blocks to make it different and to see if there is any effect on the experiment. Then we're going to put the block on the table that has been prepared. Then we're going to measure kinetic friction when we're going to pull the block with a constant speed and use the spring balance to find the pull force. Take the data and calculate the kinetic coefficient with the equation that has been provided. Then ultimately, we're going to make a graph between the pull force and the force friction. First experiment data sheet. Surface type. There's going to be two surface types. It's going to be wood to wood and wood to rubber or rubber to wood. Now, the first experiment is going to be wood to wood. Block mass in grams, the first block mass in our experiment is 128 grams, the second one is 221 grams, the third one is 264 grams. The pull force of each of them is 1.13 newtons, the second one is 4.11 newtons, the third one is 5.43 newtons. Now, the static friction coefficient or mu s is 0.9 for the first one, 1.9 for the second one, 2.1 for the third one. The average of the static friction coefficient in this surface type of wood to wood is 1.63. Now, the second one is wood to rubber. The first block mass is 159 grams, the second one is 227 grams, the third one is 281 grams. The pull force of each of the wood rubber is first one is 1.22 newtons, the second one is 3.78 newtons, third one is 6.98 newtons. The static friction coefficient is 0.9 for the first one, 1.7 for the second one, and 2.5 for the third one. The average of it is 1.36. Now, second experiment addition. The surface type is going to be the same, wood to wood and rubber wood. The first one is wood to wood. Block mass, the first variable of the mass is 128 grams, the second one is 221 grams, the third one is 261 grams. With a pull force of 0.5 newtons, second one is 1.3 newtons, third one is 1.81 newtons. The kinetic force coefficient of this surface type is 0.4, 0.6, and 0.7, with an average kinetic force coefficient is 0.56. Rubber wood. Rubber with wood. Now, block mass is going to be 139 grams, 227 grams, 285 grams. With the pull force, average pull force is 0.68 newtons, 1.78 newtons, 2.79 newtons. The kinetic force coefficient, first one is 0.5, 0.8, and 1, with the average of 0.76. Now, this is going to be the static force graph of the stated force coefficient. There, we see the pull force and the friction force. Now, we see at 1.13 and 1.22 is the same, because 1.13 and 1.22 is almost similar on their pull force. So the friction force is not going to be much of the difference, which is 0.9. Now, 3.78 has more friction force. Now, as you can see, the more pull force that you have, the more friction force that you have. Now, that's because the equation friction force equals mu K or mu S times normal force. Now, how do we get normal force? First, we are going to use this block mass, grams. We're going to take a sample from 128 grams. We're going to convert to kilograms. That means 0.128 times gravitational force of the Earth, which is 9.81. That means we are going to equal 100-ish newtons. Then we're going to time it with the kinetic force coefficient that we have found, which is 0.4. With the static force graph is 0.4. Now, as for the static force graph, for the kinetic force graph is all different. 0.5 equals 0.4, 0.68 equals 0.5, 1.3 equals 0.6, 1.78 equals 0.7, 1.81 equals 0.8, and 2.79 equals 1 for the friction force. The summary. Once the object moves at a steady velocity, the measured force stabilizes. This indicates that kinetic friction does not depend strongly on speed, and the frictional force is presumed to be proportional to the coefficient of friction. These coefficients of friction are quoted or given pair of surfaces. That's all that I can tell you today. Thank you for watching.